Welcome to the notes on dividing rational expressions. So rational expressions very similar to multiplying rational expressions, but there is one additional step. So let's take a look at this first example. If you have 3 halves divided by 7/8, you guys remember how to do this simple problem? All right, well, what we had to do is we had to take the reciprocal of the expression or the term that we're dividing by. So this, and then we would change this to multiplication. So if I was doing 3 halves and I was dividing by 7/8, I would change that division sign to multiplication, and then I would use the reciprocal, which means you just flip the numerator and the denominator. So the 8 would come to the top, and then the 7 would come to the bottom. And then at that point, when we multiply, we just go numerator by numerator, denominator by denominator, and see what can reduce. So in this case, if we did this, this would equal 24 over 14, and then we know that we could reduce the 24 and 14 by 2. Divide top and bottom by 2, so that would then equal 12 over 7. So that's how we divide. Now let's take a look at rational expressions. And here's that note. All it is it's really the same as multiplication. You're just dividing by its reciprocal. And here's the phrase that I'm going to use over and over. Keep, change, and flip. All right, that's what we're going to do for every problem. Keep, change, flip. So let's do some quick examples, and then that'll be it. So keep, change, flip. So first thing I'm going to do is I'm going to rewrite it. All right, keep the first one the same. 3x to the third times y to the seventh over 40. So we keep that the same. We change the sign to multiplication. All right, and then we flip the expression that we're dividing by. So the y squared goes to the top, and the 4x to the third goes to the bottom. And then all we simply do is just multiply across. Numerator times numerator, denominator times denominator. So this is going to equal 3 times, again, numbers first, x to the third times. Now I'm going to combine the y's. I've got a y to the seventh and a y second. So that's going to be, when we multiply same base, we end up adding the exponents. So that's y to the ninth. On the bottom, all right, we're going to have a 40 times 4 times x to the third. All right, let's see what can cancel out, reduce. The x to the thirds will cancel each other out. 3 does not go into 40 or 4, so nothing's going to happen there. So on top, I'm still going to have a 3 and a y to the ninth, and on the bottom, I have a 40 times 4. So our final answer is going to be 3y to the ninth over 40 times 4 is 160. So there is your answer to this problem. Next one. All right, keep, change, flip. So I'm going to keep the first one the same, x plus 2 squared over 10 times, all right? Again, we change that. The 5 goes to the top, the 2x plus 4 goes to the bottom. Now, all right, now we've got a factor. This x plus 2 squared, all right? Remember what that means when something's squared. It's itself times itself. So this becomes x plus 2 times x plus 2. That's over 10, and that's going to be times 5 on top. And then on the bottom, this 2x plus 4, we can factor out a 2. So we're going to factor out the GCF. We're left with x plus 2. Now let's see what will cancel out any terms that are the exact same top and bottom. We've got an x plus 2. We've got an x plus 2. So when I rewrite this is going to be 5 times x plus 2 over 10 times 2, all right, which is 20. Well, now I know that this 5 can go into both of those. So that's going to become a 4. So our final answer is going to be x plus 2 over 4. Remember, you cannot reduce the 2 with the 4. All right, cannot break up that expression. Two more examples here. All right, keep, change, flip. So this one, we're going to go right to it. All right, 6x plus 2. All right, I'm going to factor out the 2. So I'm going to be left with 3x plus 1 over x squared minus 1. That's a difference of perfect squares. So that's an x plus 1, x minus 1. Change, all right, change it, and then flip it. We got the x minus 1 goes to the top, and then on the bottom, I'm going to factor out an x. So we're going to have an x, be left with 3x plus 1. Let's see what cancels out. 3x plus 1, and the x minus 1. So what do we got left? We've got a 2 left on top, and then we've got an x plus 1 and an x. So our final answer is going to be 2 over x times x plus 1. There's your final answer. One more. Why not? All right. the first, we got this right here, all right? We're gonna have to use tic-tac-toe. Don't forget about tic-tac-toe. When I tic-tac-toe, it becomes 2x squared times 5, which gives me 10x squared. So it has to multiply to 10x squared, but add up to negative 11x. So there's my negative 10x and my negative 1x. And then I fill in the rest of the chart. 2x times 1x, negative 5, negative 1. And then here are my factors. 2x minus 1, x minus 5. So I'm going to write those in right here. 2x minus 1, x minus 5. And that's going to be over, all right, the 5x minus 25. Let's scroll down here. All right, I'm going to GCF the 5. We'll be left with x minus 5. Change the sign to multiplication and flip. 10 over, and I'm going to GCF the 2. So I'll be left with 2x minus 1. Let's see what cancels out. The 2x minus 1s are gone. The x minus 5, oops, right, move that. The x minus 5 goes away. What are we left with? I'm left with a 10 and a 5 times a 2. So that'll equal 10 over 5 times 2 is 10. Well, that reduces to 1. So this whole answer equals 1. So there you have your lesson on dividing rational expressions. Remember the phrase, keep, change, flip.